This is the lecture for Intro to Object-Oriented 1 on the Chapter 2 concepts. Creating this video to give you a chance to see some of the, see me talk about some of the concepts that are in the chapter that we may not have gone over in class, or maybe have a refresher of some of the things that we did do in class or that we may have done in a class activity. And I will not necessarily go into detail about everything, so if there's anything in this video that you have a question about, make a note of where it happens, what slide it happens on. I always bring the slides to class, so you can ask me in class. I will give you a chance to ask in class about any questions that you have as a result of this video, or of course as a result of your reading. So we'll be going over these chapter topics: parts of a Java program, print and print line methods, variables, literals, primitive data types, arithmetic operators, and some of these other data types like the string class, scope, comments. Some of these are complex topics, even though it's a relatively short chapter, so you no doubt may have questions. Really, the best way to handle those is to ask me in class or come to office hours. So a Java source code file, which you'll have had some experience with by now because you'll have had lab, contains one or more Java classes. And we'll talk a little bit more about what a class is when we get to the part discussing object-oriented paradigm. But a class is essentially a way of grouping functionality in a program and the data that allows you to accomplish that functionality. There are a few attributes of classes. You generally will see one class per file. That's the when we're starting out, that's really how we like to do things. Organize each class in its own file. There are ways to put more than one class in a file, but if you do that, only one of the classes will be public. A public class, the file name of the source code file will be the same. That helps us keep track of these things. So each class, if each class is in one file and the file is the same name of the class, you can see what classes you have in a program by looking at all the files that you have. Okay, so in the example simple that is in the book, simple.java is the file that contains the class that's called simple. Okay, and I encourage you to look in the book for the simple.java example. And so Java C here, that's mentioned here, this is a command line command that allows you to compile a Java program on any computer that has Java installed. Java C is the name of the compiler that can be used to compile programs. So we are using an IDE, so we're not using Java C. So just when you see that, I want you to recognize what the book is asking you to do. But so use the methods that you saw in lab to actually compile and run the simple program if you are following along. So this is a little bit about what the parts of the simple program are. So you see a header comment. It's ignored by the compiler. It's a way that we communicate with the readers of the code, any other programmers who might be looking at the code, to tell them something about the program. There are a lot of different things that we can tell them, and we accomplish basically documenting the code by adding comments like this one. So this header comment just tells you this is a simple Java program. It tells you what the purpose of the program is. It explains why the program exists. Okay, then there's a class header. In this case, it says public class simple, and it tells you that the name of the class is simple. It tells you that simple is a class, and it tells you that that class is public, which right now, just understand that public means that it can be used by other parts of the Java program. In other words, it's available to be used. Now we have some punctuation. These curly braces tell us where the beginning and the end of the actual body of the class is. So between the curly braces, the body of the class will exist. Okay, and that is known as a block of code there between the curly braces. Every time you see curly braces, you can consider what's within them to be a block of code. We often use that terminology. Okay, so within the body of the simple class, there is a method. So a method is so we have talked in the past about algorithms. A method is the way that Java allows us to place a single algorithm or a single piece of an algorithm into one structure in the Java programming language and give it a name so that we can identify it. So there is an algorithm called main, which is really the main program, the main part of the simple program, and it is in a method called main. And the header for the method main is, as you see here on the screen, public static void main. Okay, and we will discuss what the parts of this header mean, but for now just see that it's a public method, as just like the class simple is a public class. This is a public method. It's called main, and it has some arguments. So following the method header, we have another block of code, and within this block of code, this is where the actual algorithm for the method main will exist. It's the body of the method. So classes have a body that exists in the block of code following the class, punctuated by curly braces, and methods also have bodies that are in the block of code punctuated by the curly braces. So you must have these start and end braces. There is one line of code in the simple class's main method, and that is a print line statement, which is an output statement. It prints to the console, prints to the Java console, and it is executed when this program is run. Okay. So just to review, we've got comments ignored by the compiler. They're there for the programmers only, but they are very important parts of a Java program, you will learn. We have a class header that tells us some things about the class, whether other parts of the program can use it. That's what public means, that it's a Java class, which is what the keyword class means, and the name of the class, simple. Going back to our Chapter 1 concepts, which of these, public, class, and simple, which of these are reserved words, and which of these is an identifier that's created by the programmer? Think about that for a moment. I'll go on. Curly braces are a punctuation, and they can be associated with a class header, in which case they define the scope of the class, where the body of the class is, where it starts and ends. That's one meaning of the term scope, is to talk about the beginning and the end of a part of a program. Okay, so the curly braces define the beginning and the end, the scope of the class, where the class body exists. And of course, curly braces also are used in methods, and they define the scope of the method. Okay, and the main method is the part of the Java program that runs when the Java program is compiled and run. It starts the Java program. It's the actual first thing that will run in any Java program is the main method. Every application has a main method, and every application starts its processing with the main method. The reason why we are stressing application here is because there are other things you can create with Java that are not applications, like applets, but we do not discuss those in this week. So right now we're going to focus on applications. Okay, so you saw a number of statements. Actually, you saw one statement in the main method, but all of the statements that appear in the main method are the statements that will run when the program runs. Semicolons are another punctuation that had been discussed in class. They punctuate the end of a Java statement. Okay? There's only one Java statement in that simple program, and therefore you only had one semicolon ending the line of that program. Java comments aren't statements, right? They're there only for readability and understanding the code. So you won't see semicolons at the end of class headers, method headers, and of course curly braces are their own form of punctuation, so they themselves do not need to be punctuated. As some students noticed early on, especially in the lab, Java is a case-sensitive language, so keywords must follow the capitalization that you'll see in all the examples. So for instance, a class, the keyword class, when you're defining a class, must be in lowercase. Okay. Also, when you use a class name like simple and you capitalize the word simple, that capitalization is part of the name. So lowercase s simple is not the same as uppercase s simple. All Java programs must be in a .java file. Comments are ignored by the compiler, and we'll go on from here. If you have any questions about these things, feel free to bring them up in class. And we've already discussed these in class. We have a number of types of punctuation. Double slashes are used to demark comments. Open close parentheses are used for parameter lists, which we haven't discussed yet, but are very important and coming up soon. Curly braces are to show where a block of code starts and ends, a group of statements, and or the body of a class or a method are a type of block of code. Quotation marks are used for strings. This is one of the ways, well, the way that you know you're seeing a string literal. A semicolon is used to mark the end of a Java statement. So I'm going to skip over that last slide. Was just showing that when you use command prompt to compile and run Java programs, it looks like this, but we are using Eclipse. The console window is where the output of a Java program goes when it writes to what is called the console. And when you are running a console program in Eclipse, there's basically a special sub-window where your output will appear. And that's something you'll see in lab. Java is actually made up of a quite large library of classes with their own functionality. And what that should mean to you right now is that there's a core of Java, core functionality of the simple things that it does, and then the developers who have developed Java and many developers who have worked with Java have built on top of the language to add more and more functionality. So for instance, if there's something that people have wanted to do frequently in Java, then someone has built a way to do that to extend the capabilities. Like, for instance, there are many different things that you can do with strings of characters, and so part of the Java libraries includes things that you can do like finding substrings and things like that. Right now, just know that part of learning Java is learning where in the Java libraries to find functionality that you're looking for. And actually, just being aware that there's a library with a lot of other functionality means that when you're in the middle of a programming problem that has some familiar structure to it, you may think, I bet someone has solved part of this problem before. And what you should know is how to go and look in the Java libraries for a part of a solution to help you address the problem. And I'll be showing you how to do that in class. Okay, so once you find some functionality in the Java system, in the system of the Java libraries, There is a certain way of referring to the statements in those libraries so that you can use them. And an explanation of that explains why the statement System.out.println looks the way it does. Okay, so let's just quickly look at the structure of that for a second. System.out.println, and then it takes a parameter, programming is great fun, which is a string literal. You can see from this line that it uses a class called system because it starts out with the word system. It's in uppercase, and in Java we put our class names in uppercase like that. Okay, and system has a set of methods, its own set of methods and objects that perform system level tasks. In this case, println is the method that we're using. And what println does is it will print a string to the console. So we are saying, look in the system.out file class basically for println, and run println, basically run that function, and give it the string programming is great fun so that will appear in the console. So I'm going to skip over console output a little bit because this is some material that you'll be working on in lab. Okay, we'll be going over some of the specifics of that. But right now I'm going to pass over it to talk about variables and literals. Okay, we've discussed this a little bit already. A variable is a named storage location. As we've seen, there's a need to store data in any program. So we accomplish that by naming a location, associating a name with that storage, and then putting data in that location and retrieving data from it. Literal is different from a variable because it is literally the value that we'll be working with. So we'll see some examples of that soon. And these are all created by the programmer. And you can look in the book at variable.java for a program that's an example of that. So here's a visual representation of a storage location in a computer. So kind of like the way it works internally. Okay, you can picture this if it helps you think about variables. So each variable in the program will be associated by the computer with an address somewhere in memory, and those addresses actually have numbers. Okay, and this number 0x001 is a hexadecimal number for a that you can see over on the left here for a specific location in memory. Okay, just know that that's how the computer remembers it. That's how the computer keeps track of your variables. It has a number that it uses. Okay, and that's one of the benefits of working in a high-level language. We get to use variable names to keep track of our data because the variable names are more meaningful to us. But internally, each variable has a number, and that's how the computer keeps track of it. Okay, and when we assign a value to a variable, we store that number in the memory location that is associated with the variable. So in this case, imagine that this program has a variable declaration int value. As we discussed in class, this creates a storage location for an integer variable, or an int. Okay. And if we say value equals 5, let's say, then that would put the value 5, remember the equals is an assignment statement, value equals 5 would put the number 5 in this location. And it would be stored there so we can use it later. Luckily, we don't have to ever even see this number. What we see is the word value, and value tells us to look in this location for the number that we stored there. Okay. There's the assignment that we imagine. happens to put 5 in value. And if we use these two statements and we print the value is, so we print the string the value is, and then we follow that with a print line, and notice that the word value here is not in quotes, which means it's not a string literal. Instead, we are using the memory location that we created before. We were using the variable that we created before. So we want the value of that variable. Okay, so think about what this will print to the console for a second. It will print this string, and then it will print the contents of value. So it will print the value is 5. Okay, this part is printed as is, and this part is printed as the value that's stored. So of course, just going back quickly, so of course the value in here can change. Anytime we make an assignment like this, we can change that to any integer we want, which means that how this works would change. Okay, it would always say the value is and then some number, okay, but that will depend on what number is there, and that's the flexibility you get from using variables. The plus symbol has different meanings in Java. Using two integers, it will add the two numbers together, but in strings, the plus sign will concatenate the two strings, which means to make them into one string literal. So here we have hello space plus world. That will result in hello space world to be printed out to the console here. Okay, and we call that concatenation. And we use string concatenation because you can't have strings span more than a line like this. It will cause some problems. So what we do is we concatenate longer strings like this. So this will allow string to go over multiple lines, but what we do with it is we break the string up into substring literals, into smaller string literals, and then we tell the computer to merge them together before output. And notice that we have only one semicolon here because this whole thing is one statement. So this is an example of how a statement can be more than one line long, and that's why we need the semicolon, because we need to tell the computer when this statement ends. String concatenation works with integer literals as well. So this literal, this int here, can be concatenated onto the end of a string. So we have a lot of flexibility with that plus operator, which is great. You can do very complex things with multiple lines and different data types. So any of our variable names, there's a term, well, not just variable names, there's a term that collects all of the types of names that programmers can define, and that word is identifiers. We use identifiers to name variables. We, the programmers, create our own classes and we create our own methods. And because we create these things, we then have to give them names. So classes, variables, and names, classes, variables, and methods have their own names. Those names are called identifiers, and we programmers create them. And we just have to make sure that they are not the same as any of the reserved words, as any of the words that Java uses to identify its own functionality. There are some rules about how you can name an identifier. They have to be made up of letters, digits, and underscores. They can use the $sign. Okay. First character cannot be a digit, and of course, like everything in Java, they're case sensitive, and you can't include spaces in there. Here's a quick list of Java reserved words. So you cannot name variables any of these. And there's a reason behind all the variable names you'll see in this course. They should be descriptive. You should name a variable something meaningful. So the less meaningful a name is to someone who's reading the program, the less useful it is. So in this example, we have sales tax rate as one variable name versus TR, which probably stands for tax rate. If you were to see either of these lines in the program, you would have a different understanding of what the program does based on seeing these. It's an opportunity. Naming this sales tax rate is an opportunity to help the reader understand how your program works. So just when you're thinking up variable names for your own programs, try to come up with a name that really describes what that variable is going to be used for. Okay. Even though we have comments in our code, Java programs should be written in order to document themselves. So what that means is that the form of the program and the way the identifiers are chosen, it should be understandable to the reader of the program what the program does without any additional explanation. Of course, sometimes it's very useful to have additional explanation, but that's a principle to make Java programs self-documenting. Okay, there are some standards of practice in naming things in Java that we will follow in this class. And so when we create names, when we create variable names, we always begin variables with a lowercase letter. So California tax rate may be created like this variable, CA, standing for California, lowercase, and then capital T, capital R. Notice that because we can't have spaces in variables, we have to run everything together. But this is a descriptive name because it tells you that it's the California tax rate that we're working with, and in order to break the word up into its subwords, we just use capitalization. I'm sure you're familiar. You've probably seen this type of naming before in other places. Okay, it's called camel case because it has inner caps. So within the word there is capitalization, and which is kind of an unusual way to do things. Class names, in order to be distinguished from variable names, actually start with a capital letter, and they also have inner caps. I believe that's called Pascal case, but these all have kind of the reason that they are called camel case is because camels have humps, and so these names kind of have humps in them. There's a list of all Java naming conventions, and I will put a link to that document in the my courses. Here's a review of the primitive data types that are in the chapter. Okay, the ones we're going to be working most often with are int and double, boolean, and char, but you'll see a description of all of them in the book, and you can ask about any of them in class. Here's a detailed description of how much space they take up in memory in the computer, and that's significant because it's not necessarily significant because you're going to run out of space, but it's significant because it affects what can be stored in each thing. For instance, an int is 4 bytes, which means it has a maximum value it can store. Notice it also has a minimum negative value that it can store. Okay, so between these two values is where the value of any of your ints can be. Remember we discussed Pac-Man in the classroom and why Pac-Man would crash when someone beat 256 levels of Pac-Man. Well, the reason is that there was an overflow. When you beat the 256th level, there was no room to store a number for the next level, so it would actually cycle back to the first level, but a lot of the values would be wrong, and so it would glitch. Well, you get the same kind of effect when you try to assign a number into an int that's larger than this number. So if you try it in a program, like if you take this number, put it in an int, and then try to add 1 to it, you'll get what's known as an overflow. You can try that in your Java program if you like, and you'll get a runtime error when you run the program. Okay. Doubles are the type of decimal numbers we'll be using, and notice that they can be much larger, 1.7 and change, with 15 digits of accuracy. So 15 digits past the decimal point. So that's very large and small numbers, much larger than this number. Okay, we have options for larger integers. So there's quite a range of numbers that Java can work with, but know that it is limited. We've seen examples of variable declarations before, but we really only looked at int, I believe. So here's what you will see when you see different types of variables declared. Every variable declaration will follow this form. You'll have the name of the type followed by the variable that you're creating. Okay. I suggest you look at the examples in the book to see different types. There are different literals types as well. So to specify a floating point literal, you use an F. We won't be using much of that in this class. We'll mostly use doubles. Okay. If you're not familiar with scientific and E notation, this is a little bit of a refresher. Basically, for instance, 247.91 can be expressed as 2.4791 times 10 to the second. 10 to the second is 100, so to get this actual value, multiply this by 100, and that's what you see here. 2.4791 times 100 is 247.91. Another way to write that is using this E notation. So when you see this E notation, understand that what it is it's engineering notation or scientific notation or exponential. I think E might stand for exponential notation. So when you see the E, think 10 to the, and then the number that follows is the power. So these examples are all different versions of using scientific notation, and then what it looks like in the E notation that you will see in some programs as output, because Java uses this notation. Boolean data type can either be true or false. We're going to be using this a lot, especially in the chapter on decision structures and for the rest of our the class, because the Boolean class with its true or false values allows us to record the results of a decision and perform logic on certain values so that we can direct the course of our program. So in other words, what it does. For instance, your program will do something different depending on what your user chooses. So think of checkboxes in programs anytime you have an option in an option pane or in an app. Those are recorded with true false values, and they affect the way the program works depending on whether they're on or off. Okay, they do much more than that, but that's the basis of what they do. They turn things, they allow us to have a way of keeping track of whether certain things are true or false. They can also be the result of certain kinds of comparisons, certain kinds of operations, which we'll see. Okay. Char data type, I'm not going to go into detail there. Review it in the book. Unicode is our system of storing characters, the one that's used in Java. I'm not going to go into detail here, but it started out with a system called ASCII, and it was expanded from there. And we can talk about some of the values, but essentially Unicode has well, I think I mentioned this in class, but there are certain numbers that represent letters in Unicode. Okay, and then of course they're stored as binary. So here's a visual illustration of what you're seeing here. Capital A is 0065, and that's what this looks like in binary. A B looks like this to the computer in binary using the Unicode system. Okay, this is what the computer sees. This is what we think of when we think of what number a Unicode character is. Most of the time we won't be seeing these. We will just be working with the characters themselves. We've talked about the assignment statement. Here it is in action in an example program. This class. So it's just if you need practice, review the parts of this as example. Pause the video and do so. Or you can just go along with this. We have a class called Initialize. It's got a main method, so it's got one method, and this method does a few things. It declares two variables that are ints. Notice you can declare multiple variables in one declaration if they're the same type by just putting a comma between the names. So it creates an int month and an int days, and then it assigns 2 to month and it assigns 28 to days. You must declare variables in Java before they can be used. They also must have a variable assigned into them, a value assigned into them before they can be output. Okay? This is called an initialization. Once they have values, they can be used for output. But of course, if they did not have a value, you wouldn't be able to print out the value of them. And so if you tried to, without giving a value to them, you would get an error. So here's a shortcut way to assign initial values to variables. Right inside the declaration, you can put an initialization. So you can say month equals 2, comma days equals 28. Saves you some space, and it's nice to see default values for variables that we know have a default. And we already discussed that trying to use any variables that have not been initialized will result in an error. Arithmetic operators work in many ways similar to what you've seen in your math classes. We have one for addition, subtraction, multiplication, division, and then we have something called modulus, which we will discuss in more detail later. This is modulus arithmetic, which is a type of, well, we will discuss it later. Division, some of these work differently depending on the types that you're using. So we saw that the plus operator works to add two integers together, but with strings it will concatenate the strings. There are other examples where they work differently. These are called binary operators because they use two inputs. Okay, that may be confusing with the fact that we have a binary number system that we talk about in computers, but binary just means two. So we call these operators binary operators because they need two operands, two values to operate on, and it allows us to differentiate them from unary operators, which we'll see elsewhere. You can't divide a number by 0. I'm sure you're familiar with that. Integer division is a little bit of a special case that you'll see. So here's an example that's meant to get you to think about it. Okay, think about what is the value of 1 divided by 2. And of course, if you are familiar with mathematics, you probably think it's a half, or it looks like a half. It's 0.5. However, that's wrong. Okay. The answer is actually 0. Why is that? It's because notice that in Java, these are int literals. So 1/2 means divide the integer 1 by the integer 2. And when you divide one integer by another, the result needs to be an integer, or is going to be an integer. That's what Java is going to do with it. So when you divide 1 by 2, the value of that would be 0.5, but what Java does, it does not round the value, it truncates the value, which means it throws away the decimal part, and you end up with just the integer part, which is 0. Okay? That's the way that works. If that went by quickly, rewind the video and take a look at it again. If it's still unclear, ask me about it in class. I will talk about more examples. You may be familiar with order of operations from math class. There is an order of operations in Java as well. It allows us to, it's basically the what allows us to make sense of larger strings that include multiple operators, because we need to know which operations happen first. So there is a precedence to these operations in order for us to interpret them and evaluate them. You will be asked to evaluate operations like this in quizzes and on exams, because this is something that you'll be doing in programs. You can't make sense of a program that has operations in it if you don't know the operator precedence. Okay, so the highest priority of the operations that we've seen so far is the unary negation operator, the minus sign, when it's used in a unary fashion. In other words, when it's not used to subtract one number from another, but instead is attached kind of to the left-hand side of a number. So in other words, this -4 includes the unary negation operator. Okay, and then multiplication, division, and modulus arithmetic are the next highest priority, and then lower priority is plus or minus. So this may be similar to you, or you may have learned PEDMAS in school. And we have a similar hierarchy of operator precedence. So, for example, here we evaluate left to right. Okay, but we have to pay attention to precedence. So looking at this last example here, we can't just go left to right because there's a multiplication here. We have to do that first. So because this is a higher, multiplication is a higher priority than addition or subtraction, we do this first. So we multiply 6 times 3 and get 18. So imagine that the number 18 is there. Okay, then we go left to right for the rest of it. 6 plus 3 is 9. Okay, 9 minus 4 is 5. So then we add that to 18, and we get 23. In order to make our mathematics or operations, our arithmetic operations more clear or more correct, in some cases we can put parentheses in there. Parentheses can be used to make sure that an operation works the way we intend it to, or they can also be used as punctuation for clarity. I use them in both ways. So sometimes I have what could be considered to be unnecessary parentheses, but sometimes they're useful for clarity. Okay, so by using parentheses, you are telling the Java compiler that you want certain parts of an operation to have higher precedence. So the parentheses are processed first. So even though 5 minus 2 here, for example, is a low priority part of this expression as far as operator precedence is concerned, it actually happens second. So we evaluate the parentheses first, but we go left to right. We still go left to right. So we look within, so the leftmost completed parentheses is this, so we complete this first. Then we complete this one because it's the next to the right. And then this parentheses end here, so we do this. Then we will do the subtraction. Okay. So there are some combined assignment operators that you'll see which can be useful, and I'll just talk about one here. Let's see, do we have, okay, we'll go back. These are shortcuts. So for instance, you may have seen this in a code example. when we want to say x, so a variable x equals x plus 5, there's a shorter way to do it. We can say x plus equals 5, and that just means take x and add 5 to it. Okay. The most common way you see this is actually with the plus plus operator, which is a unary operator version of this that tells you to add 1 or increment a value. So I'm going to skip over constants for the moment, except to tell you that there is a standard for naming constants. When you see this language, I'll discuss constants more later on, but when you see this language final, it means that you're creating a storage location that cannot be changed. It's going to get a value, and that value will stay for the entire program. It's a way of, if there's an important value that you know will never change, that's the reason to create a constant. And we name them, we put underscores in them to kind of simulate spaces, and we name them in all uppercase to distinguish them from variables so that we don't try to rename them in the code. So we've dealt with string literals. We haven't talked about a way of storing strings. There is a string class. It allows us to store strings. In this video, I'm going to skip over most of the details about strings, but I did want to mention it here because we'll be talking a lot more about it. But strings, when you create a string variable to store a string literal into it, you are creating an object. So this is our first example of an object in Java. So you can declare them the same way you declare things like ints. You say string, and then you give a variable name. String, the word for string is different from int because it's in uppercase. That's because string is a class, and you're creating an object here. Okay? Don't worry too much about that right now. Just remember that when you use string, the word string has to be in uppercase because class names are in uppercase. Strings are different from primitives because in primitives, like for instance with this int number, the actual storage location for a number stores the value of 25. But objects are not stored in variables. Objects work a little bit differently because objects are more complex. So for instance with a string, the string is made up of a list or string or series of chars. So those chars do not have a simple way of being stored in one location like a number does. Because remember, those locations in the computer are single binary numbers. So a string of characters is basically a string of binary numbers. So they have to be stored and kind of stored in different places and grouped together. Okay, so here's kind of an example of that. When we store the string for a city name here in this example, so we're declaring a string object. We're naming it city name. So this is the variable name for the string, and then we're assigning into it this string literal Charleston. And this is what it looks like to the computer, a little bit different. So there's a character string Charleston that's stored somewhere in the computer, and city name is the variable which keeps track of where that data is being stored. This doesn't affect how you use it that much. Okay. So we can assign a string literal into a variable that is a string type. Okay. And there are other ways to create objects, which we'll see later on, because we'll be making our own classes of objects in this class. Strings are special because Java has allowed us to treat them in some ways like a primitive. In other words, you can do this when you create an int. You can assign into it like this. And so Java lets us use strings this in the same way. Okay, but actually when we're working with objects and classes, the assignments work a little bit differently, which you'll see in the future. So this is just acknowledging that there's this difference. Right now, if you aren't familiar with classes yet, which you won't be if this is your first exposure to Java, then this slide doesn't make a whole lot of sense to you, and that's not a problem. Don't worry about it. You'll understand it more later. Okay, string has its own set of methods that allows you to get to do things with strings or get more out of strings. For instance, a string of characters has a length, and sometimes we need to know what that length is. So there are ways to take a string variable. So in this case we have a variable named value, and it has a string in it. So we have this new way of dealing with a variable, which is to put a dot after it and then call a method. So this is probably looks very unusual to you. It's explained a little bit in the chapter, but what it means is that the string class has a method called length. So when we create a string object, we can use that method length to get the length of the string out and assign it into an int. Okay. Strings are well, I'm going to skip over strings and I'm going to skip over scope at the moment. So we will be discussing both of those things in more detail later on. I just want to get to comments for now because this video is getting long. Talk briefly about comments. There are different ways to create Java comments. We can do a single line comment by putting 2 slashes and then writing text after that. If you have a block comment that spans lines, you will see /* when it begins and // when it ends. Everything in between those two punctuation marks will be ignored by the compiler. So you can actually put a long description of your program, for example, between these punctuation marks. And then you may see this form in some comments because there's something called JavaDoc, which is a special type of comment that works with a utility program that Java programmers use to document their classes. And we'll probably not go into detail about that, but just know that it's a JavaDoc comment when you see these two things, and you won't have to worry about it too much. We are going to have a format for the programming in our course that includes comments, so that your programs will have a set structure to them where you will put your name in the comments for and a description of what the program does, and I'll be distributing that to you very shortly. It will be a template for your own projects. Okay, skipping over. So one of the things, just to let you know what JavaDoc is for, the JavaDoc utility will take comments from a Java program and actually create a web page of documentation for that program. Okay, so for instance, if you put JavaDoc comments in your class, the utility will create a page like this that documents your class. You can see that it describes how the class works, what the name of the constructor of that class is, what the main function, what the main method looks like. Okay, so that's just an explanation of why JavaDoc exists. It allows people to create documentation in web page form for their classes. And we won't be doing that. That's something that you may want to do on your own. We won't be doing that in class, but we will be looking at some Java documentation that was made with JavaDoc. So that will be familiar. And white space is very important in a program because it aids the reading of that program. And we have different white space that is used for different purposes. I urge you to look at the example compact.java, oops, going back, to see the consequences of different types of white space in the chapter. We also use indentation to demark parts of the programs. Blocks of code as they are created in a program are indented to show that they are inside of other blocks of code. We'll be seeing a lot of examples of that. And so I am not going to go into detail about the scanner class of input or dialog boxes in this video just yet. Save that for a separate lecture or video. System.exit method, also not necessary for this video. So, and I'm not going to discuss the parse methods. Look in the chapter for details on those things. But when we get to them in examples, we'll be talking about them. Okay, and that's it for this video for the Chapter 2 concepts. Again, if you have any questions about any of this, bring them up in class or send me an email or see me during office hours or set up an appointment for an office meeting at any of the times that are indicated in the course description. And see you in class.